How's it going, guys? Welcome back for another video. We are following on from yesterday's video of how to find the current taken from the supply and find the phase angle and state if the current is leading or lagging in a series circuit. Now that video will be down below in the description along with all the other formulas for these questions. They will all be down there, so if there's anything you don't know, check the description. There'll be a video for it. Now, today is going to be this question, but instead of series, it's parallel. It's quite similar, but there's a few different steps you have to take, but we'll find it together. This will be the question. If you want to follow along, get a notepad, pen, paper, and we can go through it step by step. Okay, I'm going to start on this sheet by just drawing out the diagram, because it will just help for us to revert back to. You have this. Okay, so like every question, as soon as we see henries and microfarads, we are going to be changing 0.065 henries to XL, which is inductive reactance formula. Then we have 40 microfarads, and we'll be changing XC, capacitive reactance. So we'll start off with the inductive reactance. You should have it in your formula book. Here is the formula. These dots are exactly the same as multiplying. So we have not even put the formula in. I really should have done that. Let me just show you. This is the actual formula. So we have just converted the formula and taken the numbers 0.065 henries into for L, and we have 50 hertz for F for 50. So XL, if we do it on the calculator, 2 multiplied by pi multiplied by 50 multiplied by 0.065. Put that into decimal, 20.42 ohms. Alright, that's step 1. For step 2, we have to find capacitive reactance. So we have the formula in our formula book. We have 2 multiplied by pi multiplied by F multiplied by C. That's the formula. We have pi multiplied by 50 multiplied by 4e multiplied by 10 to the power of minus 6, because it is in microfarads to the power of minus 6. Now if we throw this into the calculator, multiplied by shift, oh, now you do what I did in the last video. If you didn't see what I did in the last video, check it out, series. 1, 2, multiplied by shift, multiplied by 50, multiplied by 4e, multiplied by 10 to the power of minus 6. 79.57. Now you're probably used to finding the impedance of a series circuit, but we are going to be basically finding it again, but it's just going to be a little bit different. You'll see in your formula books this formula. IL minus IC all to the square root. So we have OR, we have L now, which is 20, and we have IC, which is 79.57. But we have to find IOR, IL, and IC. So how do we find that? We've got IOR equals V over OR, the voltage on top of OR, and IL is going to be the exact same, but instead of OR, it's going to be XL. And then you guessed it, V over XC. These will give you IOR, IL, and IC. 200 over 100 equals 2 amps. You have 200 over XL, 20.42 equals 200 over 20.42, 9.79 amps. And for IC, we have 200 over XC, 79.57. Draw this in the calculator. we have 200 over 79.57. That is 2.51 amps. So now that we have IR, IC, IL, and IC, we just fill in this formula. IR, IL minus IC squared to the square root. So IR, which is 2 amps, we have squared, over IL, 9.79, minus IC, which is 2.51 squared, all to the square root. This gives us the total current of the supply. 2 squared plus 9.79 minus 2.51, close bracket, squared. We have 7.54 amps. 4 amps. Now, to find the power factor in a parallel circuit is a bit different to a series circuit. PF, it is IR over IT. Now, this could be IT that we just got. IT is just the total current. That's why IT will be there. So we're going to have IR, which is what we already found, 2 amps. To put it in amps, on IT. IT is here, 7.54 amps. 7.54 amps. Now, the power factor is going to be 2 over 7.54. 0.265. Now, if you want to get the angle, just go shift cos 0.265, close bracket, and we have 74.6. Put in cos minus 1, 0.265, close bracket, and we get 74.6. Right, so we have IR, we have IL, and we have IC. Still don't have that ruler, so we're going to show you the phasor diagram with the calculator. Right, so I said in the series circuit yesterday that IL will always be on the top in a series circuit, but in a parallel circuit it will always be on the bottom. So we swap it out, throw IL, throw IC up here, and then we throw voltage here, and then IR just here. So similar to what we did in the series circuit, we have IC, well no, we have IC on top, so that's 2.51 amps. IL, we have 9.79 amps. We have IR, which is 2 amps. The same as the series circuit, we're going to be taking the biggest from the smallest. So we have 9.79 minus 2.51. And what does that give us? 0.79 minus 2.51. 7.28. And because this is the bigger side and we're taking away a smaller number, our angle is going to go down to the right here because it has more left over when you take it away. And as this number says, 7.28, this is 7.28. Now, thumb to know whether the circuit is leading or lagging, if IL, which we have here, 9.79, is bigger than IC, which is 7.51, 2.51, IC, IL. If IL is bigger than IC, this means it's lagging and it's an inductive circuit, because if you take away 2.51 from 9.79, there's still, I'm not too sure, around what, like 6 point something left. So it's an inductive circuit. It's an inductive circuit. It means it's lagging. But if we swap this around, if we swap this around, I'll try to keep this here for you. if IC is bigger than IL, let's say IC was the 9.79 and IL is 2.51, take them away, you have 6 and a bit on the IC side. That means it is leading because it's a capacitive circuit. A capacitive circuit is always leading, and an inductive circuit is always lagging. I hope this helped. And if you have any questions or if anything for me to go over, I will make a video on it straight away. So first comment to ever tell me what to do, I will do it. Right. Thanks for watching. See you in the next one.